Okay, here we've got a water bomber that needs to drop water on a fire that's 3,000 meters below the height of the bomber when it's traveling along at 85 meters per second. So this is a typical projectile question. Now the trick to this one is you have to remember that the projectile, when you release the water's initial speed is exactly the same as the plane, which is all horizontal to start with. So imagine the water as this sort of glob in the air like this. Initially, it's moving horizontally at a speed of 85 meters per second. And then it's going to fly through the air and eventually land on the target below. And we want to figure out how far in advance, in other words, what dx is, so that he actually hits the target. So once again, we'll set it up in the two directions. I've got my horizontal, which I call x. And in that direction, because there's no acceleration, I only have the three variables: dx, vx, and time. Now vertically, which I call the y, it is accelerating at negative 9.8 meters per second squared, so I need all of my variables. V initial in the y, v final in the y, acceleration in the y, displacement in the y, and time. Now we start populating the list given our information from the question itself. Now we know the initial velocity and it's all horizontal. There is no y component. Initially that water has a horizontal speed only. So Vx is 85 and it'll remain 85 at any point in the flight. The only thing that changes is it starts to pick up a y component as well. So there'll be a Vx that's always 85 no matter where he is, but the y component will continue to grow, starting from rest. So my initial velocity in the y is 0. That's why we call this a type 1 projectile. It's coming off flat. Don't know the final. My acceleration, as usual, is negative 9.8 meters per second squared. Remember, these are all vectors, so the negative simply means downwards. And my displacement is negative 3,000. Now it's negative because the water is falling below where it started. That's a negative displacement. And we want to figure out the time so I can take it across to my x side. Now if I look at this list, I want to avoid equations with v final in it. And the one equation that makes sense is this one. Displacement is v initial times time plus 1/2 at squared. Now we want to stay in this y column. My initial velocity is 0. 0 times anything is still 0, so I'm just going to get rid of that first term. Now we've got meters and meters per second squared, so we're good to go. We don't have to do any unit conversions or anything like that. So my displacement is negative 3,000 equals 1/2 negative 9.8 times squared. Negative 3,000 equals, now 1/2 of negative 9.8 is negative 4.9. And I can divide both sides by negative 4.9. Now this means that my time will be equal to 3,000 divided by 4.9 is 612.24. I'm going to leave a few decimals. But that's equal to t squared. So to get rid of the square, my last step is to take the square root of that number. And when I do that, I end up with an answer of 24.74 seconds. So my time is the same in the x. It's the only scalar quantity. Now all that's left is to find dx. Very simple. There's only one equation horizontally. dx is vx times time. I know my horizontal velocity never changes. My time is now 24.74 seconds to hit the water, or to hit the ground in this case, or the fire. And we work that out and we get 2103 meters. And if you round off to the right number of sig figs, 2100 meters. 2.1 kilometers away. You have to release that water.